Okay, so let's start bringing in what we did yesterday. So yesterday we saw a couple word problems. I have a word problem very similar to the one yesterday with Lauren creating her red plates and gold plates. In this case, though, Kim is knitting hats and scarves. So she's got some limitations, she's got some restrictions in terms of how much yarn she wants to use, how many hats she wants to make, and she also has some information in here about a profit, and that's where we're going to get our objective function. So if you notice, I do have a couple different things highlighted in some different colors to help us create our inequalities and to help us to create our objective function. Okay, so it says a hat, I'm reading the pink part. It says the hat uses 6 ounces of yarn and a scarf uses 9 ounces, and she only has 72 ounces of yarn to create her hats and scarves. Now I've already assigned the variables just so we're all on the same page. I have X as hats and Y as scarves. So for my yarn used, let me make sure I do this in the same color here, not get confused. We're using 6 ounces for a hat. So it's going to be 6X. She's using 9 ounces for a scarf, so it's going to be 9Y. And she only has 72 ounces, so she needs to keep this less than or equal to 72. Okay, so there's our first restriction. Obviously, she can't use more than 72 ounces because she's going to run out of yarn. Now, she also has a kind of a limitation on the number of hats. She says she wants to make at least 3 hats. So we're going to take X for hats greater than or equal to 3 because 3 is like her bare minimum that she wants to do. Now, scarf-wise, she does not have a limit on that. So scarves can be Y greater than or equal to 0. She doesn't say anything about scarves specifically. So if she makes some, she doesn't make some. She's not really picky. So there's our constraints. Those are going to be the inequalities that we're going to graph on Desmos. So let's do that. Let's grab our Desmos, just like we did yesterday. Okay, I'm going to split my screen here, and I'm going to start just typing in my inequality. So I got X is greater than or equal to 3. That was the fact that she wants to make at least 3 hats. Change that to blue so everything matches. We got Y greater than or equal to 0. We change that to yellow. And then my last one, the 6X, is talking about the yarn. So 6 ounces for a hat, 9 ounces for a scarf. She has to keep that less than or equal to 72. That's red. Okay. And let me swipe this over. Close that. And now I can start seeing my feasible region. My feasible region is a triangle, which makes sense because we had 3 inequalities, 3 constraints. So there's my triangle. I'm just going to screenshot it here, just like we did yesterday. And I'm going to throw that in my notes right on top of the graph, because again, let's let Desmos do the work. There we go. Make it a little bit bigger here. All right. And then we can see, and I'm just even going to trace it a little bit better for you here. I got constraint number 1. There's my hat constraint. She wanted to make at least 3 hats. My scarf along that x-axis there, Y equals 0. And then my last constraint staying under that 72. Okay, I'm just kind of coloring. Yeah, I'm not going to color that in. Here we go. Okay. So there's our feasible region. Sorry about my coloring. I'm trying to get through this quick so this video is not too terribly long for you. Okay, so there's our feasible region. Now again, anything in that feasible region is a combination of hats and scarves. That will keep her within her constraints. But here's the new idea. She wants to sell this stuff. She wants to make money. And she wants to sell a hat for $10, so she makes a $10 profit on a hat, and a $20 profit on a scarf. So we're going to write this objective function to show her profit, that she's making $10 for a hat and $20 for a scarf. So profit, 10x, $10 for a hat plus 20y. Okay, And now that we have this objective function, now that we have this information about her selling her hats and scarves, we can start maximizing this. And again, the way we do that is by finding the corners of our feasible region and seeing which one gives us the biggest profit. So first corner down here looks like 3, 0. 3 hats, no scarves. Corner 2 down here, we got 12, 0. So 12 hats, no scarves. And up top, this looks like 3, 6. So 3 hats, 6 scarves. Okay. Now if we start plugging that in, let's see, 3, 0. If I plug in 3 here for X, that gives me $30. If I plug 12 in there for X, that'd give me $120. Right? And then 0 for Y is nothing over there. And then 3 and 6. So this would be 10 times 3, which would be 30. Plus 20 times 6 would be 120, which would give us $150. So checking out these 3 vertices, checking out these 3 corners, it looks to me like she, in a perfect world, Kim, would probably want to make and sell 3 hats and 6 scarves, because that combination is not only going to keep her within her restrictions, keep her within her limits, but it's also going to make her the most money.